Hello, everyone. Thank you very much for your time. And my name is Marcos, so let's take a look and let's discuss a bit about fuzzing today. So first, I would propose that we get to know a bit more of the people that are talking to you today. So my name is Marcos Cardoso. I work at ETAS currently, and I am a product manager of a fuzzing tool called CycleFuzz. I work in the test and measurement world for since 2004. And I also had some time that I working in the more startup business and consulting. So this is my summary. Sungtek, would you like to talk a bit about yourself?
Sure. Hello, everyone. My name is Seung Taek Chang. I'm SDV Solution Manager in Keysight, mainly focusing on automotive. Uh, my I am more working on VTEX, eco automotive cybersecurity area. Um, it's great to in here. Thank you.
Thank you very much, Sungtek. Simon, would you give some words
Yes,
about you?
of course. Hello, everyone. My name is Simon Kreibich. I'm from Germany. I work in Keysight since 2016, and the latest project I'm working on is the automotive cybersecurity platform, which we will talk and see later as well. And yeah, the main focus is automation there. Thank you.
Super. Thank you very much. So this is what we have prepared for you today. In this time that we are going to spend together, we are going to make a quick introduction about fuzzing because sometimes we have people that know about fuzzy. Sometimes some people the topic is new, so we're going to do a quick introduction. Then we're going to discuss a bit about the main challenge that we have seen in customers when they choose a fuzz solution. And then, of course, we're going to mention how this challenge can be taken. And then Simon is going to show a demonstrator, is going to make a demo for you of one of the tools that is the result of this partnership. Also, how then we show in a practical way how we can tackle those challenges. In the end, as always, you have your chance to do the questions. Feel free to put your questions uh, at any time in the Q&A, and then let's discuss together. So let's start then. Fuzzing. What fuzzing is? So fuzzing, in essence, is a testing methodology where we have a target and several inputs created randomly are sent to this target. So this target can be different ones, can be a piece of software. In this case, fuzzing is called source code fuzzing, for instance, can be a software, and they sent this fuzzer sends several inputs for this software. This target, in the case of the automotive, can be an ECU, computer that goes inside the car, and then the first test sends several inputs created randomly to this ECU. What are the main motivation today in the industry, in the automotive industry, to do fuzzing? And this is a very interesting topic because fuzzing exists actually for a while in the IT industry. And there are even open source fuzzers that we're going to discuss a bit also. But in the automotive industry, there are some motivations that we have seen from our customers. One is in the ISO 21434. There is the recommendation to use fuzzing. And then it's not mandatory, but we can see customers doing more and more. And the other motivation, and we have seen also with some users and some customers, is to use fuzz testing as a methodology to increase the software robustness, because there are functional tests and requirement-based testings, and fuzz tests is as I heard from one customer, you see fuzz testing as an additional point of view to test the issue. So in summary, this is fuzzing. I have a target. I sent several randomized or pseudo-randomized inputs, checking for vulnerabilities and for software robustness. And there are different motivations that we have seen in our the people that we are interacting with. So when I talk about motivation, there are, as I said, the ISO 21434 that is directly mentioned in the UNR 155 when you talk about European legislation. But we also have seen talking to customers around the world in Asia, US, so China, Japan, Korea. So there is this huge interest across the globe for fuzzing. The regulations are mentioning fuzzing in different ways, but the interest is quite global, which is good, but also brings some challenges that we're going to mention. I'm going to mention a couple of slides. Now let's go a bit deeper in the understanding of fuzzing. So as I mentioned, the targets can be a piece of software or an ECU. In general, when I have a piece of software and I start fuzzing, this piece of software can be a software that goes embedded in an ECU later, but can also be any other software. In general, what we use is a source code fuzzing, a methodology that is called source code fuzzing. In a source code fuzzing, basically we have the fuzzer who's going to create all these inputs. And then I have some instrumentation in the software called stubs that were actually the randomizing inputs is going to be inserted in the software. Then the software is run with these different inputs. And there is also sanitizers. Sanitizers are kind of instrumentations that we can include in the software to check if there is, for instance, a memory overflow or which part of the software were covered. So basically, in summary, in a source code fuzzing, I have access to the source code. I make some instrumentation of the source code, and then I send these inputs, these randomizing inputs, and run the software and check for vulnerability or robustness. This is source code fuzzing. And reminding this information in the source code fuzzing then is necessary to have access to the source code. There is another type of fuzzing that is called protocol fuzzing, or in other, the word protocol fuzzing can be not clear, especially in the customers from US, so can be also called communication protocol fuzzing. What is the concept of protocol fuzzing? The target is an ECU from a car. Can be an ECU physical or can be a virtual ECU also. And then the inputs to try to check or to crash this ECU, they are sent through the communication protocol. So how it works, then there is a test cases that are generated, and then this test case are generated can be with the fuzzer or separate from the fuzzer, depending on the strategy. And then the interface to the ECU can be CAN, can be some IP, DOIP, can be different interfaces with the ECU. And then what the fuzz do in this case is send several randomized inputs through the communication protocol and observe the reaction of the ECU, the reaction of the target, and check if the target is reacting accordingly. So basically, this is the concept of fuzzing. I send the randomized inputs, communication protocol or source code fuzzer, and then I always need to make the check, the health check, to see if the ECU is responding accordingly. So this is in a very simplified way to say what fuzzing is. Of course, we could spend a lot of time here. Sometimes we give workshops, we stay 4 hours or 6 hours talking about fuzzing. But in summary, this is the concept. I will be happy to share more details, or feel free to reach us out in case you need some more information. Now, the second part of our discussion today here. What are some challenges that we have observed in customers when doing fuzzing? And this is, on my personal view, it's interesting because we have challenges from the technical standpoint, but challenge from standpoints that is not that technical. And that is quite interesting point. So let's see what are the main ones that we have seen from customers and users. One of the challenges is choosing a fuzzing method. So question here is, which fuzzing should I do? Should I do source code fuzzing? Should I do protocol fuzzing? Should I do both? This is a recurring question. This is also another topic that we can stay hours talking about this. There are people who prefer source code fuzzing, people that prefer protocol fuzzing, people that prefer both together, or other methods also. There are some hybrid modes. There are many ways. The way I like to put when to choose a method is basically we need to consider which level of information do you have about your target and how much time you have to invest on this. Let me explain. To put the background of this, let me explain 2 or 3 concepts here. One is black box, gray box, and white box fuzzing. So, on the right side, in a white box fuzzing, is a scenario that the user have access to the whole information about the target. The user has access to the source code, to the documentation. They can change the source codes and etc. In this case, then it's called white box. In this case, it's possible to do, for instance, source code fuzzing because you can access the source code and you can make instrumentations and you can do functional tests, but also explorative tests. In the very other side of the spectrum, there is the black box fuzzing. The black box strategy is I have a target, but I have basically no information about this target. It's really a black box. In this case, you don't have access to the source code. You don't have access, you cannot change creating the instrumentation in the source code. So in this case, protocol fuzz testing is more suitable because you have an ECU, you have the CAN communication, that is the UDS ISO, there are the standard CAN communication that you can find in regulations, and you can send the message to try to crash the target, even if you don't have any information. So in this both sides of the spectrum, in the left side, black box testing, you can do protocol fuzzing because you don't have many information about the target, and the setup is very fast because basically it's connecting the ECU in a communication protocol, doing a minimal configuration, then you can start testing. But there is a limitation on how you can check the health status of the target, and then you're gonna show here today in the demo. In the very right side, in a white box test, you have a lot of information. You can change the target and etc. So you can have more effective results, but you need access to the source code, and you can take much more time to do this instrumentation. In the middle, there is the concept of gray box. Is then when you have limited access to the source code or limited access to the target. Then in here, depending on the information that you have, then you can use protocol fuzzing or source code fuzzing or do a hybrid. What is a hybrid is I can make the stimulus to the ECU through the protocol, but then you can check some variables in the software. So this is where the gray box concept lies. So to choose a method, it really depends. Which information do you have? How much time do you have to invest in the instrumentation? And how much time there is available to perform the test. So this is what we have discussed. This is what we have talking to users, and the common opinion that I have from users that at least what I hear more is the willingness to do both. When it's possible to do source code fuzzing and protocol fuzzing, then is what are the preference that I have seen, at least to people that I'm talking to. Second challenge, choosing a fuzzing tool. This also, in my opinion, very interesting challenge because when we talk about fuzzing, there are different options in the market. You can buy. So let me explain this spreadsheet here that you see. You have, as I said, source code fuzzing, protocol fuzzing, and also automotive focus tools. So tools of protocol fuzzing focus in the automotive. On the other hand, you can do in-house tools, or you can do fuzzing with open source tools, or you can pay for a proprietary fuzzer, right? So this is what we have seen. And here also, which tools should you use also depends what are your boundary conditions. And we talk very openly with customers that come to us and say, no, I prefer to use open source. And then we discuss openly about this. And what is really interesting, on my opinion, is that depending on the use case, any of those options may make sense. Let's go one by one here. When you talk about source code fuzzing, there are some options like AFL++ or Peach Fuzzer or Leap Fuzzer. So these are some open source libraries that can be used. On the side of proprietary fuzzer, what I have interacted with and we have seen customers doing and are available in the market are Code Intelligence and Peach Fuzzer. I'm going to focus more on the protocol fuzzing here because this is the focus of the whole, or this is a bit more the focus of the presentation today, talking about protocol fuzzing. So when we talk about protocol fuzzing, there are two lines of discussion, let's put it this way. One is more generic fuzzers, like where we see, for instance, in the open source, if this is AFLnet, or say BlueFuzz, or some fuzz, open source fuzzers for Bluetooth, for Wi-Fi. And on the proprietary fuzzers, we see Synopsys Defensics and Beyond Security. They are fuzzers. Our understanding, they came from the IT industry. They have may have some functional features for automotive, but they are more generic. And you can also go in the direction of a dedicated automotive focus protocol fuzzer. So in this case, what we have seen in the open source, or for, let's say, more free of usage, is customers getting the open source tools and developing an in-house solution. Or when we go for proprietary fuzzer, you have some options here: Script CycleFuzz, Intrepid Vehicle Spy, and AutoCrypt fuzzer. So those are what we have seen. I target here Script CycleFuzz because this is what you're going to see in detail today. And yeah, and the question here is also when to choose which of those tools. What I see, the decision is basically on how much time you also have to invest, if you have internal resources, and also the liability, and how fast do you want to have updates. So open source, for sure, it's there, can be used, but it's not necessarily plug and play. For the open source, in general, there is a need to create a user interface or to adapt this open source to run in your specific use case. And there is also the question of the liability or the responsibility and the support of the code in general is taken by the community or with the person that inside the company developed the solution. On the other hand, but the benefit is that it's for free, but you spend internal resource. On the other hand, the proprietary fuzzer, you have to pay for it. In general, you pay a license or pay use or subscription. There is a price, but the benefit is that you have the tool ready to use. You have a technical support you can call for. In our case, we listen to the market what are the main features, and then we introduce the feature in the product and we release to everyone. So basically, when you pay for a tool, then you have access to new features. The liability in general is there in the terms and conditions, and the responsibility of the tool is from the supplier. And then you have a very much less resource needed inside your company because you're buying a tool. So here's the decision also depends if you have resources to invest, if you want to take responsibility to do the software in-house, open source can be a solution. If you are focused on the results and focus on your testing your ECU and bringing your ECU to a high quality, then make more sense to buy a tool and work with a partner. This is our view, and there is a third one that is also an interesting challenge that I have to confess that in the beginning I didn't think there would be. I underestimate. That is, deployment around the globe. As I mentioned before, there are fuzzing is being used around the globe. No? So many different countries, different cultures, and different level of knowledge from the users also. What does it mean? Does it mean it does mean that this fuzz testing is not only performed by experts in fuzzing. The fuzz testing may be performed by persons that are more on the test execution task. And also the results may be shared with people that are not experts in fuzzing. So the need for a reporting with more descriptive reporting and the need to more easy of use is really high because of this deployment around the globe. Then I show here, this is a typical fuzzing, protocol fuzzing report. You have the message that was sent to the ECU, then you check the instrumentation message to check the ECU health. It's not that hard to see, but it's also not that simple. Requires some investigation, some checking, some analysis. These reports, they may have millions of lines. So the need to have simplified user interface and simplified reporting structure is also something that we have seen from our customers. And this is exactly where this partnership with Keysight was born, because at ETAS, we have talking to customers that are doing fuzzing themselves. We have a tool called CycleFuzz that they perform it. But then we have facing customers, they need a more comprehensive solution. They don't want just to do fuzzing. They want to comply with the whole ISO 21434. They don't want just a report like this. They want to report more more descriptive or more fitting to the ISO. This is where this partnership born, actually. And that's why we are here today doing this to show you this other side, that is how we include fuzzing in a whole solution for cybersecurity. All right, and to keep going on this, what I just said, on the solution level, then I would like to invite Seung-Taek Chung for give this overview for us.
Okay, thanks, Marcus. So as Marcus mentioned previously, Keysight offers a comprehensive system designed for automotive cybersecurity. Our solution targets electronic control unit, and including telematic control unit, and groups of ECU within a functional domain, hardware in the loop, and the entire vehicle. The Keysight Automotive Cybersecurity Test Platform is a scalable solution that enables you to validate the robustness of your ECU, TCU, subcomponents, and the entire vehicle against the cyber attacks. Here's how our solution works. It combines hardware, software, and services. The hardware connects to the device on the test via all relevant interface, such as cellular, 2G, 3G, and 4G, and 5G. And also we are providing some CVTX interfaces. And also we provide Wi-Fi, Bluetooth, and CAN, and automotive Ethernet. And the software runs attacks against the various interfaces, and it validates your system using the Keysight threat databases. Let's look at the more details on the next slide. Here is more architectural overview for Keysight offer. As you can see here, on the left side and in the middle, that is our solution architecture. And on the right side, that is a system on the test, which is more like a vehicle or subsystem or ECU and component level. We can do it some scanning, fuzzing, exploiting, and attacking using our Keysight cybersecurity test platform. As you can see here, on the left side, we have operator interfaces such as automation, OpenTab.io. We can do some of the automation tool. We provide some tab test automation platform. And also all the attack modules are supporting REST API, which can be very easy to automate the whole process. And also we are providing some interactive UI, which we can do some IoT security assessment software. In the middle, we provide some system module, updating those kind of attack modules. We have a vulnerability scanner, and further Wi-Fi attack module, and Bluetooth attack module, IP attack module, and CAN bus attack module. And also we also can integrating third-party software such as ETAS CycleFuzz tool, and also your proprietary third-party software testing tool. In the core controller, we provide a test controller and analysis module and reporting module. So we can do some tests, and also we can create some test result in the system. Let's look at more information on the next slide. Here is our PassWave lab operation for automotive cybersecurity. It is kind of a management software. We do control all the system hardware interfaces, and also we can control all the cybersecurity test tools in here. Overall purpose of using this kind of a software tool is kind of managing TARA and test request and cybersecurity goals. And also you can do some test planning and tracking and result management and report management using these software tools. And also we are providing some automation tool, as I mentioned earlier, which is open source tab, opentab.io. This is basically C# or Python as programming language, and we provide free plugins available at opentab.io website. And it is dedicated plugins from Keysight and Keysight partners available. It is easy, customizable, and extensible, and flexible integration of third-party hardware and software. We'll show this kind of tab environment in the demo session. Here is some example of Scrypt CycleFuzz CAN fuzzing integration in our tab environment. Scrypt CycleFuzz DLL embedded into tab, which is a test automation platform. And this environment we require ETAS licenses. And these licenses usually are subscription-based and incremental functionality to follow some future enhancement, such as automotive Ethernet. And it is easy to add test case coverage in the test automation platform. And here is a more explanation of our automotive cybersecurity test platform. As you know, SDV is an enabler of advanced driver assistance system with powerful computers, faster internet networks, and more sensors and connection to the outside world are all part of that. And however, each of those brings more cybersecurity risks. Understanding and securing this new vulnerability is crucial for protecting against the cyber threat. As we have discussed, there are industry standards with IS SAE 21434 plus the United Nations legally binding security regulation UNR 155 and UNR 156. Together, they establish a framework that aims to ensure the safety and security of vehicles with measures such as risk assessment, cybersecurity management systems, and incident reporting protocols. Connected vehicles are particularly vulnerable and requiring cybersecurity measures integrated into the design. To achieve this, we must integrate these compliance requirements with the tools and processes we already have in place. And as those test cases evolve, your CSMS and SUMS must also adapt. You need a flexible automated test platform to keep track of those tests. This integration will streamline our workflow and ensure we consistently meet a regulatory standard. Let's pass to Simon for the demo session.
So let me introduce our SA8710A automotive cybersecurity test platform and go through a demo. So we are starting with our test automation platform, which is, as mentioned already, used for automated test runs. And it aims also for easy regression testing, as you can design a test plan and load it the next time if you want to run it again. Also, if you want to include any preconditions or post-condition steps, for example, if you have a power supply which at the beginning of the test execution you want to turn on or configure in any sort of way. You can do this, and the same thing for after the test. If you want to ensure that next time if you run it to ensure regression testing, that it is in a clean state when you test it again. As also already mentioned, TAP is using a plugin concept. So if you have anything, for example, a additional instrument bought by Keysight, then you can find most likely a plugin which you can just add, and you will see it then here on the left-hand side, just as our cellular interface, which I opened here. Also, again, if you want to add your own plugins or test cases, you can do that as well with following the SDK and in a programming language C# or Python. And then let's have a look at our plugin for the automotive cybersecurity test platform. As you can see, we have two tools in here yet. One is the IoT security assessment, and the other one is, of course, the script CycleFuzz from ETAS. If we have a look in here, as already mentioned, we cover a lot of interfaces such as cellular, Bluetooth, Wi-Fi, or also CAN. So let me open a test plan, which we will then execute against our DOT. For that, let me just quickly show you how our connection looks in our demo room. So on the left side, we can see our test platform, which is connected on the right side to the automotive test bench. There we have multiple interfaces, and for our demo, we are using the CAN interface through OBD. Okay, so let me here go through the test plan. The first thing we want to do is, let's just assume we don't know our DOT. We want to make use of one of our IoT tests that is a UDS server scan. So what we are going to do right now here is we are going to scan for IDs in the range of 600 and 800. If I'm going to execute that, I will see on the bottom left the logging of the current state, where it is and what it does. And if we wait a couple of more seconds, we should see that the test finished with a verdict. And after that, on the bottom right, we should see a PDF report. In that PDF report, we will have now the result of the servers which responded from our device under test. You can see that the verdict is inconclusive. Why is that? Just simply because a server scan does not indicate any pass or fail criteria. So that's why in that case, it is inconclusive. But of course, if we run the CycleFuzz, we will have a pass or fail verdict, as the moment we have one failed test, then we consider it a fail run. But let's talk about it in the next step. So once we have our IDs listed in here, we then take it to the CAN fuzzing, which has a couple of properties on the right side exposed. And now the goal is to take one of the IDs, enter it as the request and response ID, select the number of test cases. In our case, for the demo purpose, we are going to run 300, but of course you can run it up to 100,000 and even up to millions, and a couple of other properties in here. If we are going to execute it now, we will see on the bottom left, again, a logging, which we are at the moment. We can see that we are running a total of 300 test cases. Currently, we are at 100. What are the current passed and what are the current failed tests? We can see already we have 5 failed test cases. And once the execution finish, now we have 6 failed test cases out of 300. We are waiting for the report. Once it is downloaded, we can see it as well here at the bottom right, with the number of test cases being run and also what the failed test cases are. Because of course the past test cases, you just acknowledge them, but you don't have to do any further investigation. If you want, you can still do that. But of course, we are interested in the fail test cases. So here we can see the 6 fail test cases with the additional information of where exactly they're coming from and what the payload was. Now our automation platform asks us, okay, hey, you have 6 failed test cases. Do you want to perform a rerun to rule out any false positives? This is what we are going to do right now. And then we have a couple of options. Number one is we can run 300 tests again to see if there were any preceding failed test cases. We can only select the 6 failed test cases and run them, or we can even pick our own test cases by number. So you can, for example, select the first test case, then the 5th test case, and then the test case number 250. In our case, let's execute the failed test cases. We want to execute them once, and also we don't want to have any preceding test cases. So if I'm going to rerun them, I expect that 6 test cases are going to be executed. And as we can see in the logging here, those 6 test cases failed again, which means right now we would have to investigate that and check what is the reason of that and fix that in the software. And as I mentioned, if I stop the run of the rerun, now we have 6 failed test cases, and therefore the verdict of the test case is fail. Okay, that would be it for the automation tool. And one thing I want to add on top of that is our lab operations software. Here is our Pathwave lab operations for automotive cybersecurity. And what we did here is to get into the next level to say that to link it with the UNR 155 specifically. So here we have an example of our CAN test cases, which we have in our platform. And we are linking right now the requirements and mitigations to the test cases which our platform provides. For example, the UDS test cases, but also, of course, CycleFuzz when in the document it asks for the fuzzing part. If I open them, I can see then when we want to test for the requirement 19.1, extraction of copyright proprietary software from vehicle systems, we are going to run those 2 test cases. I will there then get a pass or fail. I will also have the report attached. And in the end, I will be also able to create a report for my whole test cases. So I can always have a look and see what is the current state and have one document where it links to our documents, for example, from our cybersecurity platform, but also to the CycleFuzz reporting. Okay, it for our demonstration.
Super. Thank you very much, Simon. Very interesting to see the Keysight and ETA's solution working now. And just to recap a bit on what we talked in the beginning of this webinar, no? So there are several challenges like choosing a testing method, choosing a testing tool. And when you talk from choosing a testing tool, you can go from developing an in-house tool with open source, for instance, or buying a tool like CycleFuzz that is just do fuzzing and you do the rest, or go for a whole solution, as you saw here from Simon. And it's really nice to see how a solution complements and add features and add functionalities that may add value for the customer. For instance, the UDS scan, the fact that report goes in PDF in a more interpreted way. So remember when I said distributing across the globe is a clear feedback that we got from users. So the reporting, more interpreted reporting is very important, and other features, and the direct connection with the UNR. So really nice to see that in the whole spectrum of possibilities to choose a fuzzing tool with the partnership between Keysight and ETAS now, we are offering the whole solution, or Keysight is offering the solution. Thank you very much.
Everyone.
Thank you.
Bye.
Bye.